Dave Staublin here. We're continuing on with our sequences and series unit. We just talked about definitions for sequences, and we now know that these are terms, these are term numbers, and if we wanted to know the value of term A5, we would go to the fifth term and say the value of A5 is 64. Well, it would be very handy for us if we had a formula to describe the value of any term in the sequence, so that if we wanted to know the value of term number 80, we could figure that out. Well, as it turns out, there are two ways to do that. There is a formula called a recursive formula, and there is also an explicit formula. And I would like to describe both of those to you and how we derive those. So I have two columns here so far. The sequence, which is 4, 8, 16, 32, 64, and we have them labeled A1, A2, A3, A4, and so forth. And then we also have the term numbers labeled 1 through 5. And what I would like to do is talk first about the recursive formula. Well, what we're going to do is define recursive as the following. The value of each term is based on the value of the previous term. So here's how this works. Our very first term is the number 4. A1 has value 4. And so what we do is we take, in order to find the value of the next term, we take the value of the previous term, and in this case, we multiply by 2 to get 8. Then we take the value of this term times 2 and get 16. And then 16 times 2 is 32. And 32 times 2 is 64. And so on. So when we write a formula like this, this is what we want to consider. We always want to have a starting value. So the very first term has value 4. Then, I'm going to leave a little gap here. What we're doing is we're saying take the previous value, which is 4, and multiply times 2 to get 8. Well, 8 is the second term, and we use the previous term to figure it out, right? That's 4 times 2 is 8. And then what we do is we take A2, which is 8, and we multiply times 2 to get A3, which is the next term. And then we take the A3 term times 2 to get the A4 term, and so on and so forth. So if we wanted to convert this to any term, if we were to say the nth term, it's based on the previous term, which is n minus 1, and then it would be times 2. And that is a recursive formula. So if we wanted to figure out what is the 20th term, well, if n is 20, then it would be based on the previous term, which would be the 19th term times 2. Well, if we look up here, do we know the value of the 19th term? No, we don't. So to find the value of the 19th term, we'd have to know the value of the 18th, but we don't know that one. So to know the 18th, we'd have to know the 17th, but we don't know that one. And so one of the disadvantages of a recursive formula is that if you want to find a term very far along in the sequence, you have to know all the previous terms. So that's a disadvantage. An advantage of the recursive is that it's very easy to derive the formula. Okay, so let's talk about explicit. It would be very nice, because of the disadvantages of the recursive formula, to have a formula that instead of being based on the previous term, it's based on the term number. And that's what an explicit formula is. The value of each term is based on its term number. So let me show you how that might work. Our very first term has value 4. And one of the things that you'll notice is that for every term, we're multiplying by 2. And in a sense, the farther down you go in the sequence, the more 2's you're multiplying by. So what we're going to do is we're going to say this first term starts with a multiplier of 2, and if you square that, you'll get 4. Now, the next term in the sequence is 8. Our multiplier is 2. What exponent gets us 8? Well, 2 to the third equals 8. And our next term is 16. Our multiplier is 2. What exponent do we need? We need a 4. 2 to the fourth is 16. Are you seeing the pattern yet? 2 to the fifth is 32. 2 to the sixth is 64. And so if we want to know any one of the terms in the sequence, we just have to figure out how to write this formula. Well, it seems like the nth term is going to be 2 to some power. We just have to figure out what that power is. And we want it to be related to n, so let's take a look. This exponent, how is it related to the term number? How is this exponent related to the term number? And so forth, and so forth. Well, it looks to me like if you wanted to find term number 5, you would do 2 to the 5 plus 1. And so if you wanted to find the nth term, you would go 2 to the n plus 1. And that is the explicit formula. So now, if you wanted to find the 20th term, you would do 2 to the 20 plus 1, and you could find the value. So the advantage of the explicit formula is that you can find any term in the sequence just by knowing the term number. The disadvantage is this is oftentimes very difficult to come by. It's hard to get this equation. Whereas the recursive formula, it's easy to get the equation, but it's a lot of work to get a term value that has a high term number, because you have to do a lot of calculations all the way up to that point. Okay, that's it for this part of sequences.